Alright, hey, it's Nick here. So, playing around more with my Garmin bike computer and programming it using a language called Monkey C, and put together kind of an old school display. I'm not sure it's terribly useful, but it was fun to put together. So, I was staring at the gauges in my Hyundai last night and thought that would make a cool bike computer. So put this together, and this is basically what it looks like. And then at the bottom is the odometer. The odometer is your trip distance. It resets when you start a new activity, and it's gauged down to tenths of a mile. And the cute feature that I put in just now is the tenths number actually scrolls, so it looks like a mechanical scrolling system. The other digits snap so that you can actually read them, but the tenths is scrolling smoothly. I didn't want to try recording this while I was riding my bike around town, so I recorded this using the simulation in the IQ Connect tool set. But anyway, that's basically what it looks like. So the code is open source. The app is going to be posted on the Garmin App Store as soon as it's approved. And the code is pretty straightforward. If you take a quick look at it over here, basically it's a standard complex data field, so compute is called whenever new data comes in, and basically I record the cadence and the speed and the distance if they're available. If it hasn't connected to the cadence sensor and you don't pick this up, sometimes it fails, so just being extra careful, making sure that there's no null pointer exceptions around. I cap the cadence at 125. The dial caps out at 120, so it'll peg a little bit past the end of the gauge, just for cool effects. Speed is only working in miles per hour. Distance is only in miles. And I just do some basic conversions here, some debug print statements commented out, and then get the width and the height. This is really geared towards the Forerunner 920, but I wanted to at least, code the height and the width into variables so that I have a little bit of generality. But basically, first thing we do is we draw the odometer, so 4 digits using a draw num method, and basically just pick off each digit for the first 3, the hundreds, tens, and units. And then for the tenths, I actually have a separate flag which makes the screen inverse video, and also tells it that it should do the scrolling effect. And I need to know what the hundredths are so I know how far to scroll the 10th digit. The tachometer, it's not a tachymeter. The tachometer is drawn by calling drawmeter, and the speed is also drawn by calling drawmeter. And the rest is just all support code. So draw num draws a single digit, basically draws a rectangle for the background, and then draws the digit. If it's the last digit, meaning it's reversed videoed, then we do all of this stuff, which basically draws the current digit and the subsequent digit, right? So val is the current digit, val plus 1 mod 10 is the subsequent digit, and it draws those instead of starting at the bottom of the rectangle. It moves them up on the screen a little bit. The first one gets drawn at y coordinate new y, which is y with an extra bit of displacement, where the displacement is the height of the rectangle scaled by how far we are through the current tenths of a digit. And then the second one is drawn another height units down on the screen. So it's just number magic, nothing fancy going on there. And then clipping doesn't work until you get to SDK 2.3, I believe, which my Forerunner does not support. So I simply draw a background color rectangle above and below my true rectangle, which wipes out the top and the bottom of those digits that I drew. And then I go ahead and draw the outline of the box to make that nice, boxed in appearance. And the meter is just more drawing methods. So draw the arc that's going to hold the ticks and the numbers, and I just did some hardwired stuff here. For miles per hour, I code it by green, orange, and red. Otherwise, I draw it in black, but when you get above a certain point, it'll change the color to red. So that gives me my danger zone for my RPMs. And then I draw tick marks by basically defining a starting angle. This is basically 135 degrees counterclockwise, but Y runs from top to bottom, 0 to positive, so everything gets reversed, but it makes it work. Draw a certain number of ticks. If we're at a tick per label value, I go ahead and add a label, and the label will be, based on what the tick number is times the amount of stuff per tick, and I'll make the length of that tick mark slightly longer. If we're doing miles per hour, I also do my color coding again based on whether you're on tick mark 0, 2, or 4, so those are hardwired magic numbers. If we're at the critical tick, then I start coloring things in red, and then I call the tick method to actually draw the tick mark, and I bump up my angle by pi over 2 divided by the number of intervals, which is the number of ticks minus 1. Yeah, this draw arc method is by the way, it's, you can read what the arguments are, but it basically makes it a little general purpose. And then drawing a single tick mark is just, plain old cosine sine for x and y. And I come in from the perimeter of the circle by length amount, where length could be, 8 or 11 for a short or long tick mark. And if I passed a label to this other than, an empty string, I'll go ahead and draw that label in a tiny font next to that tick mark. That's really all there is to it. It's a lot of fun developing for this environment. Monkey C takes me a little bit of getting used to because it's loosely typed. They do what's called duck typing. So I found myself having to do things like this, because if I left cadence as, just cadence coming from info, I couldn't do things like divide it and have it be meaningful. And distance I had to turn into a long because I was trying to do modulo operations on it and it was crashing my computer. So a little bit of getting used to the loose typing, but it's a fun environment. It's really well supported. The API is very well documented. You can sideload into your device without pushing to the store. I'm doing this through Eclipse. It's pretty easy to download the SDK, install it, and get on the air in 20 minutes maybe. There's a good simulator, which you saw earlier in the video, that lets you do your first order development, and then, like I say, once you think you've got your code working, you can slide load it into your device by just dropping it into a directory on your device from Eclipse, and then once all that's working, you can push it out to the store, and then everybody can download it and play with it. So anyway, that's what I've been doing today for fun. Take a shot at it if you like. Let me know if you have any questions. Have fun. Thanks. Bye.